Hey again, guys, and welcome back. Um, if I can use some of my university degree for a little bit, you catch me in medias res right now. So I actually filmed this video before, and everything went to crap, so here I am again. Today I want to talk about servos. Servos are basically just like motors, but instead of doing 360-degree rotations, they actually do about a 90-degree sweep of this arm. They are also geared, so the torque is multiplied from a motor that's around this size. They typically come with servo horns, which are the attachments that go on top here. You usually get like a circle, you get a cross, you get a single arm like this, and you get a two across like that, and they come in a huge variety of sizes. So you've got these little guys, which are, I think this is a 9-gram servo. They come far smaller than this and far larger than this. Just on hand, I have this MG996R, which is fully metal geared, big motor inside, lots of torque, and this plastic 9-gram, which has a tiny motor inside, not a lot of torque, and is super light. The construction is very interesting. You have a whole bunch of these gears stacked on top here on a bunch of shafts. So it sort of looks like that, and you pull it apart. And inside there you have a potentiometer, and that potentiometer is driven by the gear set and gives absolute positioning back to a microcontroller. That microcontroller that's on board is this guy here, which activates the motor depending on a digital signal that you send it. Now, some of these will be called analog, some of them will be called digital. The only difference is one has a dedicated chip, the other one has a microcontroller, as far as I know. And they always have 3 wires. The most typical voltage for a servo to run with is 5 volts, and the 5 volts will always be in the center of the wire. You'll see different color codes. This one is black, red, and white. This one here is brown, sort of reddish, and orange. But it doesn't change the fact that the positive is in the middle, the ground will be over to one side, and the signal, which is yellow on this one and white on this one, will be over on the other. The reason for that is they come with these kind of DuPont connectors on the other end, and no matter how you put it, you won't be damaging anything because you can't reverse polarity. Since your positive is in the middle, that means all you'll be doing is grounding a signal or not. So that's important. So how do these things work? Well, you can get these little units here, which are basically a microcontroller that will create the signals necessary, and we will talk about signaling shortly. And these are actually, they're made to test servos, but I mean, nothing's stopping you from just straight controlling servos with this thing. Basically, you can position it in any of its sweep, or you can make it sweep back and forth automatically, or have it in neutral position, so right in the middle. So let's connect up a servo and see what's going on. Okay, so here's a servo. It is connected. I'll actually just flip it around. Okay, so watch that arm. You see that? These arms are installable kind of anywhere you want because all you get on the top of a servo typically is a toothed gear, like so. So yeah, this is like a motor with built-in feedback. You don't actually need external feedback. And I think a servo is a great way, especially these guys, they're very inexpensive. They're only like $2 each or something like that. Is a great way to add physical movement to your Arduino. Because a lot of us like coding, but like coding when we have a physical, real-world stuff that happens. At least that's my case. And so servos are a great way to get the outside world reacting to your Arduino. The other great thing about servos is that Arduino already comes with sketches that'll get you up and running. So let's head over to the computer let's put a sketch in an Arduino and see what the signaling looks like. So here we are on the desktop, and I'm just going to open the Arduino IDE. I did update the IDE, so it should look a little different. Maybe it does, maybe it doesn't. You just go over here and hit the examples and scroll down to servo, and then you have knob or sweep. I believe sweep just goes back and forth continuously, same as the servo tester does. But let's go with the knob because I think most of you will want to control things. So I think the knob will give us that said control. So I'm going to open this up. And let's go through this line by line, but honestly, it's really not that complicated. So it uses the servo.h library, and then it creates a servo object to control a servo. I believe you can add a whole bunch by adding servo and then giving it a name, but for now, this is just one. Then you need a pin to put your potentiometer on, and this one gives you a 0, so it has a value of 0, pin 0. And then you need to declare a variable that will actually save, where the Arduino will actually save the value of a analog pin, so on pin 0. So we're going to hook up a potentiometer to this guy here. Then in the void setup, we just, this is a command from the servo library. So my servo dot attach, so it attaches the servo on pin 9. So basically it means that the servo we declared up here will be active on pin 9, which is a PWM pin, so that works for us. Then down here in the void loop, our value that we declared up here will be equal to what pin 0 is reading, but that'll give us a number between 0 and 1023. So the Arduino IDE, or the example here, is using a map function, which I can look at in a different video if you'd like, but for now just know that it maps this val value, okay, which is between 0 and 123. It rescales it to be between 0 and 180, and I believe this will be the degrees in which the servo will turn, or actually the steps in which the servo will turn, because the servo usually does 90 degrees of turn, I think. Then it'll write the val to our servo, which will give us a signal coming out of pin 9. And then it'll wait 15 seconds. Again, you can clean this up because delay is not very efficient, but I know you can't just keep throwing signals to the servo. It's going to get confused. It does need a little bit of time between the signals. So let's just upload this to my Arduino Uno and let's go give it a try. Make sure this compiles, which I think it will. It is now uploading and it's good to go. Let me bring you back onto the bench. We are back at the workbench, and you'll notice I have an external power supply hooked up. I have it hooked up and running at 5 volts. It is powering the Arduino. It's coming out to some flying leads over here. I have 5 volts and ground coming to each sides of my potentiometer, one and the other. Then I have this white lead going to our AO, which will give us our analog read value. For our pin 9, I have this flying lead out here, which we will plug to the servo in a second, but I want to show you what the signal looks like. So I have my scope hooked up, and if you'll notice, if I turn the pot, the signal changes. Now I want you to see in between here, we are at 5 milliseconds per division, and you'll notice there's about 15 milliseconds, maybe a bit more, between our signals. So let's zoom in a little bit to our signal here. If I just go this way, and I will move the cursor over a bit, not that much. Okay, so my pot is wound to minimum right now, and if you look here, at this point we are at 1 millisecond per division. We get just a bit more than 2 milliseconds of pulse width, and that is to give us our maximum value on our servo, which actually equals to 180 degrees. So I was wrong. I thought it was 90 degrees, but it turns out I don't think my little servo tester is any good anymore. I have been abusing it. I will turn my pot all the way to the other side. As you'll see, it'll shrink, 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 and it should bottom out around 1 millisecond. This one's a little bit lower than that. And apparently halfway, the midway point for all your servos is 15, 1.5 milliseconds. So that's basically our minimum value to our maximum value. That's what a servo signal looks like. Getting rid of the scope signal now, we can try to see what this looks like on an actual servo. So the reason why I have my external power supply is because if you're running more than one of these tiny little servos, then in fact I would say even if you're just running one of these tiny little servos, you should use external power. Now the good thing is you can power this servo by itself, the 5 volts on the red and ground on the dark colored one. And as long as this ground is connected to your Arduino ground, you could then just feed this a signal. This here does not have to be connected to the same power supply as your Arduino. So if you wanted to run this at a little bit higher voltage, get a little bit more torque and a little bit more speed out of it, you can totally feed most of these servos up to 6 volts, and some specific servos will go up to almost 9 volts. You just have to check with the manufacturer of your servo. As long as this ground here is tied to your Arduino ground and your signal is tied to your Arduino signal, you should be okay. So here I go, I'll connect this up. We've got positive, which goes in the middle, and we've got the negative, which goes over on the dark side, and we will put this signal in the signal port, and now we should, I'll hold this upright maybe so you can see, be able to control our servo. And here's all the way to one end. You can hear now the servo is making noise. I don't know if you can hear that. Let me put it up to the mic closer. So the servo is struggling because it can't quite reach its full stop, but the control is making it go further. But here we go. I'll spin the pot really slowly. Looks like this one has a burr on one of its gears too. This is a used servo. It wasn't a plain previously. And there we go, all the way to the other end. So you go from one end to the other. And the speed will be determined by the manufacturer of the servo, the voltage you give it. We could crank the voltage a little bit more, but we're feeding the Arduino from the same voltage. So this is pretty cool. But now here's where the external power supply really comes into its own. I will connect this massive servo. This here is a full metal gear. This thing weighs a ton too. And if you just want to see how much torque this thing has, I'm just going to not even touch this. Look at it react to starting and finishing to turn. Don't forget that little motor that's inside is spinning way faster than this output shaft here. And therefore, there's a lot of momentum in there. Just put the servo horn on. The servo horns are typically generic. They're about the same size for all manufacturers of servos of the same class. Okay, put this in there, and just so you can see it easier, look at that. And trust me when I say these servos, these metal gear ones, are extremely powerful. If you put a servo horn tight in here, you're going to hurt yourself if you pinch your fingers. This is absolutely nuts. So this is great for like robots and robotics, and for RC cars. And there's even mods you can do to servos to take out their end stops, and so it'll just spin in that direction forever. So that's pretty cool too. So if you have any questions about servos, leave them in the description below, but I think this is simple enough that you should just go out, buy yourself some servos, and try to make a project with them. And if you do make a project, please let me know in the comments because I want to see it. I hope you liked this video. Thanks again for watching.